Hello and welcome to Dev Maths and Statistics Refresher Course Lecture 10, and welcome also to STATA, the program that I'm sure that you will spend most of your year enjoying a lot. It's the main statistics program we use with the MSc courses. It's freely available to all Dev staff and students while you're registered Dev. If you go in the, lost the browser, if you go in to the portal, so here, this is the main Blackboard page. So for here, we can see our course. You scroll down to the bottom. Somewhere near the bottom, there's usually this site, software and support. So software and support takes you to a list of all the software you can download. So you can grab hold of Maple while you're there. Latest versions of Excel and Word and so on. And Vivo if you want to do some qualitative analysis. SBS is the other main program we use. OneNote, you know, but Stata is what we're looking at. And it just gives you details of what it does, the licensing requirements, the terms and conditions you have to sign up to, and most importantly at the bottom, the downloads. So you've got it for Windows, you can install it in Linux as well, and Mac computers. So everything is there for you, and you should be able to download that whenever you like. And it's also installed in all the labs on campus as well. So what can we do with it? Well, firstly, let's try to, well, actually I should notice that I'm going to be typing all the commands into down here, which makes it a bit difficult to fill. You can run the whole thing using these window menu commands, but we tend not to most of the time because we like to be able to store the commands we've used in lists of commands called do files. So you can refine your analysis and build it up and repeat it and share it with other people and show what you've done and so on. And have much more control over what happens. So possibly the simplest command is to put browse, which tells it to show you the data. So here's the data. And I apologise in advance for the spelling mistakes I'm bound to make as I try and film this. So at the moment there isn't any data, so there's nothing to see there. But the data is going to come in columns like this. Unlike Excel, you can't just have different forms of data randomly spaced around the tables. It all comes in columns for each field, and also the name of each variable is going to go into this box up here, the grey area, instead of A, B, C, D. But it's easy to see if I show you. So if I try and type in this data for the coffee, I'll show you how we did that analysis, to show you how you can do that in Stata 255, nothing happens. This is because I'm in browse, which is the best way for looking at the data, because it protects it. You can't change it. So if you're just looking at your data, much better to be in the browse window, because otherwise you never know, you can accidentally change a number and you can never trace what on earth happened. If you definitely want to change it, like we definitely do now, because there isn't any data, you want to go for edit, which gives you the same kind of window, and now you can start typing in 255 and so on, and just type in the rest of the data like that. So that's all the data. You can see it's made up a name for the variable var1. If we click on here, look at this properties thing, you can then just directly change it. You usually do this with a code as well, but let's just do it quickly to this. You can also, in the one below, put a label, household coffee production, kg. And it's also guessed that it's a floating value, which means like a scale value, this is the format and so on. And there you've got your first list in the variable list here. Okay. So once you've done that, great, what can you do? Well, you have to go back to here to type in where you want to do something. So it would be nice to know something about, this is where I always put too many M's or too few M's in this. Summarise. So we're going to summarise the thing. All you've got to do is type in the variable name. Even that you don't have to type in, because if I just type in cough and press the tab button, it knows there's only one variable that starts with cough, so it just completes it. So it saves you time everywhere. A comma and detail. So I've just, oh, it's gone. I typed in summarise coffee, comma detail, and it just gives you a load of basic descriptive statistics. No need to type any formulas. It's giving you the mean, standard deviation, variance, also skewness and kurtosis, If you want to know what they are, remember mean is the expected value of the variable x. Variance is the expected value of x squared minus this squared. Then skewness is based on the expected value of x cubed. So it tells you how symmetrical the distribution is. Kurtosis is based on expected value of x to the value of power 4 and so on. So it's giving you all that. It's giving you the mean, the median, 255. It's giving you the minimum, the maximum, the lower quartile, upper quartile, and some other 5%, 10% values. So, pretty comprehensive statistics just by typing summarize without having to do any formulas at all. Then when we come to the test, what we really want to know is, what does this tell us about the accuracy of this 2 through 3? So we did a t-test by calculating all this stuff. But if you have the data in Stata, then you can just type in t-test coffee equals 233. And if you haven't spelled it wrong, it just does it for you. So again, it spits out a few summary statistics, then it tells you what it's going to do. Null hypothesis is the mean is equal to 233, and it gives you all the alternative hypotheses. So the one we wanted was this one here, where the alternative is that it's not 233. So this is giving you the probability that the absolute t-value, which means the t-value comes out, ignoring the plus or minus sign, comes out bigger than the critical t-value. Bigger than the one you've got is 0.0177, which is exactly what we found out. So the t-value corresponding to this mean 256, this compared to this divided by the standard error gives you this t-value. The chance of getting a t-value bigger than this positive or lower than that negative is 0.0177. And because that's less than 5%, we reject it. We reject the null hypothesis at the 5% significance level. If we had been doing, for some reason, we were trying to say, oh no, we reckon it's more than that. So we were trying to reject this. We have to decide that in advance. In that case, the alternative would have been that it's bigger than. So we decide before we do the test, we're not going to reject if it comes out lower, only if it comes out bigger. In that case, the probability comes out as half that value there. And of course, as we see down here, the chance of getting one less than that is very high. So there's no way you can reject the idea that it's less. There's no way you can reject it in favour of less because the mean is actually higher. So that doesn't mean anything in this case. So the choice always is between whether you're doing a 2 or a 1-tail test, and the probability is half as big. But that's just interpretation. The point of this is that just doing this is so much quicker and easier in Stata. It's almost instant. But before we leave the coffee one, what happens if I do this? CI mean, I spelled it wrong in. If I type in CI mean coffee, and CI stands for confidence interval, we get this output. So give us the mean of the coffee. It's give us the sample mean again. Great, we've had that before. But okay, you get it with the t-test, but it's giving you the confidence interval directly. So you can be 95% confident that the mean for the population of the coffee interval of the coffee harvest among all households is somewhere between 237, 275. And note that the thing we were testing, 233, is not inside this confidence interval. It's just below it. So the confidence interval is another way of saying, okay, based on this data, we can be fairly confident that it isn't 233, because that's not inside this confidence interval. So you can get confidence interval by doing a t-test or as a separate standalone command. So that's how you can do the single sample t-test and a confidence interval when you have one variable. So in the next video, I'll go on to look at the more sort of powerful case when you have more than one variable, and we'll look at how you can do some analysis in that situation, including the 2 sample t-test. But for now, thanks for watching.